Seeing refers to the process by which our eyes and brain receive, interpret, and make sense of visual information from the environment. But in the universe, there are different systems for vision, each of which sees the environment around them in a unique way. So, if different creatures see the world differently from each other, what the world looks like and how do machines see it? In this video, we'll delve into the fascinating world of machine vision and explore how machines can see and make decisions based on visual information. To better understand what it means to see, we need to go into the quantum world. Newton's laws of motion do not apply in the subatomic realm. Instead, new laws of motion are in effect. In the quantum world, there is no linear motion. Instead, the movement of particles is in the form of radiation due to their very small size. The movement of particles is influenced by a complex interplay of multiple factors, including electromagnetic forces. Electromagnetic forces are fundamental forces of nature that drive the movement of photons, which are the smallest constituents within an atom. The wavelength created by the movement of photons is in the form of light, and we see different wavelengths of light as colors correspond to different frequencies. On the other hand, the color spectrum refers to the range of colors that our eyes can see and is defined by various wavelengths of light. Human eyes are capable of detecting light in the 400 to the 700 nanometer range. Within this range, we can distinguish 7 main colors. However, humans are not the only creatures capable of seeing colors. Other animals can also perceive colors, but their range of color vision is often different from ours. For example, birds can see ultraviolet light, which is beyond the range of human vision. This gives them a unique perception of the world, as they can see things that are invisible to us, such as markings on flowers that help guide them to nectar. On the other hand, some creatures, such as dogs and cats, have limited color vision compared to humans. They can see only shades of blue and yellow but cannot distinguish reds and greens. But what about machines? They might have a different way of seeing the world. Machines do not perceive color in the same way that we do. Instead, they use sensors and algorithms to capture and analyze the light, which allows them to see beyond the range of visible light. This opens up a world of new possibilities, from detecting heat signatures to seeing through fog and smoke. Machine vision can also be trained to recognize specific patterns and objects, which makes it an important tool for a wide range of applications, from robotics to security. If you've ever wondered how a self-driving car can see the road, how a robot can inspect products for defects, or how your phone camera can recognize your face, then you've encountered machine vision in action. But how does it actually work? Let's take a closer look. First, machine vision starts with image acquisition. This involves capturing an image or a sequence of images using a camera or other imaging device. The type of camera used depends on the application and the type of information that needs to be captured. For example, a machine vision system used in a factory might use a high-resolution camera to inspect products for defects, while a self-driving car might use a stereo camera to create a 3D map of its surroundings. Once an image is captured, it is processed to extract useful information. This typically involves removing noise, correcting for distortion, and enhancing the image to make it easier to analyze. The next step is feature extraction, where machine vision systems identify relevant features in the processed image. This can include detecting objects, recognizing patterns, or tracking moving objects. Once relevant features have been extracted, machine vision systems analyze the image, and finally, the agent uses the information obtained from machine vision system to make decisions or take action. This can include controlling a robotic arm to move an object or steering a vehicle to avoid an obstacle. In conclusion, computer vision has opened up a whole new world of possibilities, giving us the ability to unlock the secrets of our surroundings and revolutionize the way we live and work, from motion analyses to object recognition. But the journey has just begun. In our next video, we will delve into the thrilling realm of machine learning and deep learning, where we'll explore how these cutting-edge technologies are taking computer vision to new heights. So don't forget to share your thoughts, like, and subscribe to stay updated on content and insights that help you to stay ahead of the curve in the world of artificial intelligence.